Hello everyone, myself Aryan Gidam, and today we are going to discuss on the topic molecular flux. Before directly jumping on the topic, let me show you my another teammate or group member. There is no one and I am single here again too. Okay, now let's start with the topic what is molecular flux and how it plays a crucial role in momentum transfer, thermal conductivity and diffusivity. Combining all the three builds the foundation of transport phenomena, which is very basic in engineering physics and in biological systems. Okay, now let's start with momentum transfer. When different layer of fluid moves with a different velocity, the molecules from one layer collide with the molecules of different layer. Because of this collision, the transfer of momentum due to the molecular motion causes the viscosity to come into the picture. The molecular flux of momentum quantify the amount of transfer from one layer to another layer across a surface due to the molecular collision. In gases, generally the faster moving particles from the different layer collide with the slower moving particles of the different layer, transferring momentum in this process. This gives rise to the Newton's law of viscosity, where the shear stress is proportional to the viscosity gradient. Next, we move to the thermal conductivity, which is generally transfer of energy, heat in gases and liquid, transfer from the movement of molecules carrying their own kinetic energy in them. Molecules from a hotter region moves towards the colder region, bringing their own energy with them. The molecular flux of energy is what we interpreted as the heat conduction. According to the Fourier's law, the heat flux is directly proportional to the temperature gradient. Molecules are constantly in motion, colliding and transferring their energy. Just this time, instead of momentum, we have thermal energy with them. Okay, now let's talk about the mass transfer or diffusion. When we release a perfume in one part of the room, we generally see that it's eventually spread in all part of the room. This is because molecules are naturally tends to move from the higher concentration to the lower concentration. The molecular flux of mass is generally governed by the Fick's law, which states that the mass flux is directly proportional to the concentration gradient. In this case, the molecular flux, the net migration of particles from one region to another region, the rate at which it appears, it causes as a diffusivity, and it depends on the molecular speed, collision and medium of the transfer. If we zoom out all the three processes, momentum transfer, thermal conductivity and diffusivity, these all three are generally governed by the same molecular principle. These are, the first one is random molecular motion, collision, and the third one is concentration, temperature or velocity or gradient. This is beautifully unified in the kinetic theory, which shows that all the three properties are related to the mean free path, molecular speed and collision frequency. Well, understanding a molecular flux is very essential in practical application like designing of heat exchanger and chemical system, predicting pollution or dispersion, understanding blood flow or drug delivery in biomedical science, aerospace and combustion system. Essentially, it is at our heart and of how we understand and design system where fluid, heat and particle are generally in motion. Okay, now let's jump to the problem solving where the main fun begins. Let's start doing question on molecular flux. We got our question 1. Inside, three parallel plates are separated by two fluids and shown in the figure. We got three parallel plates. They are separated by two fluids as shown in the figure. This distance we call it as y1. This distance we call it as y2. And this is plate 1, this is plate 2, and the velocity of the first plate is v1 in right direction, and the velocity of plate v2 is in opposite to first plate. The fluid between the first and the middle plate with a viscosity mu A. The fluid between middle and the second plate with viscosity mu B. What should be the value of indicated by double X in table has so as to keep the plate in the middle stationary? We have to find the value of the X. Means we have given with some table. In this table we got 3 rows. We got y1 in centimeter, y2 in centimeter, v1 in meter per second, v2 in meter per second, mu A in centipoise, mu B in centipoise. We have got the value of y1 in both the rows, 2x x minus 4, 3, 4, 2, 5, 1. Okay. Now, what should be the value of x indicated in table so as to keep the plate in the middle stationary? Okay. We have to find the value of x. To keep the middle plate, to keep the middle plate at stationary, velocity of the middle plate, velocity of the middle plate should be 0. Which means this middle plate, the velocity of the middle plate should be 0, so as to keep the middle plate should be 0, to keep the middle plate at the stationary position. Okay, let's start solving. To keep them we got to know that velocity of middle plate is Vm should be 0. Okay. means that we got Vm equals 0. Also we know that force is equals to tau, torque into area. According to Newton's law of viscosity, Newton's law of viscosity, we know the value of tau, it should be mu dV by dy. Substituting this tau in place of this, we got to know the force equals tau into area. According from Newton's law, we got mu equals dV by dA. Here mu is the viscosity of the fluid, v is the speed of the plate, and y is the distance between the two plates. To keep Vm at 0 means to be stationary, means the force acting on both plate 1 and 2 should be equal. Which means F1 equals F2. You know that tau equals mu dV by dy. Putting the value of tau into area equals tau 1 A1 equals tau 2 A2. We got mu 1 dV1 dy1 into A1, mu 2 dV2 dy2 into A2. We are assuming that both the plates have same area, means A1 is equal A2. We got A1 equals to x2 equals A. Therefore, we got mu1 dV1 dy1 equals mu2 dV2 dy2. This we got the equation. Just we have to put these values in this equation to get to know the value of unknown variables. We got this. Okay. Let's start with the case 1. In case 1, we have to find the V1. We have got Y1, Y2, V2, mu A and mu B. Okay. The previous equation we got, we can write in the form of mu1, a velocity of middle plate minus velocity of first plate upon distance between them is y1, mu2, velocity of upper plate minus velocity of middle plate upon distance between them is y2. Thus we have to just substitute these values in this equation so as to get the value of the unknown variable. Let's start. We have got the mu1, it's 4. Velocity of middle plate, it should be 0 so as to keep it in a stationary position. So we got the velocity of middle plate is 0. Velocity of first plate we got is 1. Distance between them, we have to find the velocity of v1, so we have to find the distance between them is 1. We have got the velocity of mu2 is 5. v2 we have 3 minus 0. The distance between them is 2. We have to find this. We got minus 4xx equals 15 by 2. So we have got the value of x equals to minus 15 by 8. We got it at minus 1.875 meter per second. This minus sign indicates that the value of x in opposite direction with respect to the first plate. We have put the value of the first variable xx. And the value of case 1, we got x equals minus 1.875 meter per second. Now we are solving for case 2. In case 2 we have to put the same equation we have got. mu1, a velocity of middle plate minus velocity of first plate by distance between them. mu2, velocity of upper plate minus velocity of middle plate upon distance between them. Just substitute this value in this equation and we will get the value of xx. In case 2 we have got mu1 equals 2. Velocity of middle plate, it should be 0 so as to keep the middle plate at stationary. Velocity of the first plate we got minus 4. Distance between them is 5. We have got the velocity, viscosity of the second plate is 1. Velocity of the second plate we got 3. 0. Distance between them is, we have to find this. So after solving, we got 3 into 5 by 8, 15 by 8 means in case 2 we have find the viscosity is a distance between the two plates 15 by 8 and 1.875 centimeter. For case 2 and for case 1 we have got the value of xx is minus 1.875 meter per second square. Question done.